All right, moving on to the elimination method. Now, when it comes to using the elimination method for solving systems, ideally we would want both equations to be in standard form, meaning the x and y's are on one side and the constant term is on the other. Now, for both equations, we want them to be in standard form so that the like terms are all lined up. Like the x's are all lined up, the y terms are lined up, and even the constant terms are lined up on the same side of the equal sign. Okay, so that's the initial setup that we want for the elimination method. Now, what we want to happen for the elimination method is that we want to be able to add these equations vertically, meaning combining like terms from one equation to the other, such that one of the variables is going to add up to 0. So if you take a look at this first example, when we add both equations vertically, that the x terms are going to add up to 0. Negative 2x plus 2x adds up to 0. That's what we want to happen in the elimination method. And what else we want to happen is, as we add the rest of the terms, 3y plus a negative 1y is 2y. Negative 23 plus 5 is negative 18. We want to be able to find a nice little equation like this to be able to solve for one of the two variables. All right, so again, what happened in the beginning here is that we added these two equations together. The x terms dropped out, leaving us with y terms to add together and constant terms to add together. And when we added those together, we are left with this equation for y, which we can solve very easily. All right, so now that we have a solution for y, we have to be looking for a solution for x. So again, we're going to use one of the two equations from the system to help us find that x value. So I'm going to use the second equation to help me solve for x. I'm going to plug negative 9 in for y. When I simplify that left side and isolate the variable x, I'm left with x equals negative 2. So that completes my ordered pair solution for this system, negative 2, negative 9. Now skipping over to number 10. Now in some situations, we may need to manipulate or change an equation or two to try to get one of these variables to go away. Because as you can see here with number 10, if I were to add straight down the like terms, I'll get negative 9x plus a negative 2x is negative 11x. So the x's did not go away. And then 5y plus 5y gives me 10y. So the y's didn't go away either. Okay, so the elimination method did not work here. So, as I said before, what we need to do here is to change one of these equations slightly so that one of the variables will drop out to 0. Well, you notice that the y's seem to be ready to get eliminated. All we need to do is change the sign in front of the 5y to a negative. So that's what I'm going to do. I'm going to go ahead and multiply both sides of the second equation by negative 1. All right, so by doing that, I now get 2x minus 5y equals negative 20 for my second equation. I'm going to go ahead and keep my first equation as is. All right, so there's my second equation as is. I'm going to go ahead now and add these two equations together. 2x plus a negative 9x is negative 7x. Negative 5y plus 5y is 0. And a negative 20 plus 20 is 0. Okay, so again, what we want to happen in the elimination method is we want one of the variables to drop out to 0. And it happened here. So we're happy. So now we're left with an equation that says negative 7x equals 0. Solving for x, we get x is equal to 0. Right, so now we're going to have to solve for y. All right, so using the second equation, the original second equation, I'm going to plug 0 in for x. Solve for y, get y is equal to 4. Thus, my ordered pair solution for this system is 0, 4. Taking a look at number 11. Again, we notice that if we add straight down, neither of those two variables is going to go to 0. So we need to make some changes so that one of those variables is going to go to 0. Now, the way you change your equations depends on which variable you intend on getting to 0. So, like for example, you can get rid of the y's by multiplying the second equation by 6, right? Because that's gonna put a 6 in front of this y, so that the y is going to drop out. Or you can multiply both sides of the equation by 2. And that's what I'm going to do here, because I want to get rid of the x's. All right, so multiplying that second equation by 2, I now have 14x minus 2y equals negative 22. I'm going to keep that first equation exactly the same, because with that equation exactly the same, now when I add my two equations together, my x's are going to go away. And I'm going to be left with 4y equals negative 12 and have an opportunity to solve for y. All right, so now I have a solution for y. I need to go find a solution for x. All right, using the first equation, I'm going to plug negative 3 in for y. And when I solve for x, I get x is equal to negative 2. So my ordered pair solution for that system is negative 2, negative 3. Okay, so let's take a look at number 13. 13 is an example of a system where we're going to need to manipulate or change both equations to try to get one of those variables to drop out to 0. All right, again, the way you decide how you're going to change your equations is by first deciding which variable you want to get rid of. All right, so I'm going to decide for this example that I want to get rid of the x's. Okay, so I need to be able to change the coefficients of the x's such that when I add them together, they add up to 0. So I'm going to multiply the first equation by 3. And the second equation, I'm going to multiply both sides by negative 2. Again, when I multiply the first equation by 3, I'm going to have an equation that looks like this. 18x plus 15y equals 57. And when I take the second equation and I multiply both sides by negative 2, I get this equation. Negative 18x minus 14y equals negative 52. All right, so you can see here by changing those two equations in the manner that I did, I was able to get the coefficients of my x terms to be values such that when I add them together, they add up to 0. And that's going to leave me an opportunity when I add the y terms and the constant terms to solve for y. All right, got to finish the job, solve for y. Now I need to solve for x. All right, so using that first equation, plugging 5 in for y, I solve for x, and I get x is equal to -1. Thus completing my ordered pair solution, -1, 5. Okay, that's it for this lesson. Let's move on to the next lesson video.